Today's podcast episode is a special treat. We have a heavy-hitting panel to discuss the CHIPS Act and the state of the semiconductor industry. We're joined in the lobby by Rich Simoncic, Executive Vice President at Microchip, Russ Garcia, the CEO of Menlo Micro, and Moore's Lobby regular Michael Knight, President and CEO of Endries International. This panel was originally one of the keynote sessions for Industry Tech Days, but it was so good we have it for you here in the podcast as well. So let's get started. Thank you to all of our panelists for being here. We've had panels discussing the chip shortage in prior years, but it feels like we're moving into a new era and that the CHIPS Act will be a big factor for the semiconductor industry. So I'm curious to get your perspective on how the CHIPS Act will impact each of you. And Rich, let's start with you.
So the CHIPS Act for us is a good thing for the United States because it helps bring awareness to this vital industry. So that's what we're interested in and just the overall awareness in this critical resource that we have and that we need for almost every product that we use or produce within the United States.
Michael, what's your perception on how the part shortage has changed, and is that related to the CHIPS Act, or is that a totally different conversation?
I think it's a different conversation. I don't see a direct correlation. I mean, obviously, the part shortages it's been top of mind, right, for the last couple of years. And then the inverse of it's become top of mind this year as we start to see gluts accumulate in certain technologies. Although that said, I think it's also pretty interesting, right, that there are pockets where we still have shortages. Certainly, microcontrollers, which are near and dear to Rich's heart. There's some issues still in there, which there is some relationship downstream to the CHIPS Act. But specific to your question, I think what's starting to happen is the two things are kind of getting conflated. And we're starting to see maybe some misunderstanding on what's really driving the CHIPS Act and what's really driving our relationship or lack thereof with China at the moment.
Russ, as a CEO of a company making high-end specialty parts, how has the CHIPS Act impacted Menlo Micro and your business?
Well, Menlo Micro is in a kind of unique as far as this goes. We hear in the CHIPS Act, we hear a lot about TSMC and of course microchips and global foundries and this drive to single digit nanometers for AI and microcontrollers and all that stuff. And so there's a leading edge technology aspect to this thing. We're a small company. But even more unique in this, we're a small company that needs to manufacture for ourselves because we're a material science place. So we're kind of this tweener because CHIPS Act is really laid out for large manufacturers to, bring back because of security issues as well as leadership issues. There's a multitude of things that you want to have large manufacturers in the U.S. Then it's kind of broken out where most of the semiconductor industry now doesn't have factories like Rich and the Microchip team does. They're using foundries, and so then there's a big R&D component to the CHIPS Act. Well, we fall in the middle of this thing, so I'm going to spend an awful lot of time in D.C. just trying to make sure I'm on everybody's radar because we need a round off error in this manufacturing portion of the CHIPS Act, but we're very involved in the R&D portion. And you see a lot in the CHIPS Act documentation of crossing the chasm, right? The valley of death and getting this advanced R&D across the valley of death. So we're pretty involved in there. And this becomes really important for a company like us. We just purchased a factory. We're trying to bring that up and make sure that we drive this technology home.
In a breath or two, Russ, what is the valley of death?
The valley of death is there's a lot of technological innovation that, especially when you get into hard hard tech is hard to get funded, right? Because it's capital, especially around the semiconductor businesses. And Rich knows this well. He's involved in a lot of different small companies like us, and that getting that investment to go through all the hurdles and all that's unknown in order to bring those innovations to true scale in manufacturing. It's really hard, and especially since we've moved. On one hand, the fabless business, fabless business model made that better. But in other instances, when you're doing material science and ground up kinds of things, it's actually made it harder because there's no place to build this stuff. So that's what I mean by the valley of death.
Yeah, that makes sense. Rich, Microchip has been investing in this space prior to the CHIPS Act. From your perspective, what is the CHIPS Act doing right? And for you and for Microchip, is it an addition? Does it boost your business, or is it kind of separate to what you were already working on?
Before I answer that, I'm going to, add on a little bit to what Russ had said. Semiconductor development is the most capital intensive industry. And it is very difficult for semiconductor startup companies to find venture capital with the wherewithal to see it to fruition. You are talking $100 to $500 million invested before you see your first $10 million of revenue. And it often takes 5 to 10 years to get there, unlike a software startup where you can get to $10 million in the first 6 months. So that is the benefit to the program to some of the smaller companies, because you've got funding now for long-term critical investments in the U.S. For Microchip, it's a little bit of a different story. We already produce almost 50% of our wafers in the U.S. in multiple fabs. We support just over 20% of all semiconductors for aerospace and defense applications, mostly built in America, right, on our shores in one of our 5 semiconductor facilities around the U.S. So for us, what this insight into our business, it gives visibility to a greater audience of the importance of investing in this technology in the U.S. Right? Many companies over time have decided to move outside of the U.S. We have made a conscious decision to support these industries and keep that investment in the U.S. And the additional dollars from the CHIPS Act helps make that investment sustainable, right? So whatever we're doing here for the CHIPS Act, we want to make sure that it creates a sustainable business model to continue to invest in U.S. semiconductor creation and manufacturing.
Yeah, Rich, it makes a lot of sense that Microchip would be in an excellent position, and that investment is already paying off for Microchip. So to see it expanding for the industry should be a rising tide sort of situation. Michael, from your perspective, what's the benefit of the CHIPS Act?
I think the obvious number one benefit is just along the lines of what Rich was talking about, right? The encouragement that the act gives the semiconductor supply chain to invest, in essence, anywhere in China. I mean, the CHIPS Act, right, is intended to encourage investment in the U.S. But there's the flip side of that coin is anywhere but China, because the act does allow for U.S. companies to partner with non-Chinese companies, with partner companies of the U.S., Australia, etc. So it's when you get into the weeds, it's not all red, white, and blue, but it certainly is not Chinese red. So I think that's the number one benefit. The number two benefit, or maybe the 1B benefit, is this whole notion of investing in something here that's just critically important to the future of this country. Once upon a time, I think back in the 90s, if I have this right, the U.S. semiconductor manufacturing accounted for 30+% of the global output. Today, it's 12%. And the SIA has been pointing this out for quite a while and pointing out that it's a real existential threat, especially given where things have clumped up. And the thing that I find encouraging about the CHIPS Act is that at last we are starting to invest in keeping this stuff at home. One of the reasons why a lot of it's in Asia is the Asian countries have long been very generous with, whether we're talking about tax holidays, free land, reduced tax rates, loads of incentives that are significant. Over a 10-year period of time, China alone was offered over $50 billion in incentives to the industry. That same period of time, the U.S. offered zero. So, not to belabor the point, but I think this is there is a point here, Danielle, that I really want to get to. This is a good first step. This is not a silver bullet.
That's a really important takeaway, and I think a first step is the first step we have to take to get progress. So speaking of silver bullets and first steps, Rich, I know there's been a lot of investment recently, especially in the wide bandgap semiconductor, silicon carbide, gallium nitride space. I understand that Microchip just had a pretty significant investment going into Colorado for a plant that includes some wide bandgap. Can you talk about the future of how semiconductor technology is progressing and what those investments might look like?
So the significant investment, silicon carbide requires very different manufacturing technology to compare to conventional silicon. Much like what Russ is doing with Menlo Micro, requires very different manufacturing tools and capacity to make it work. So what we've done is we've partitioned a part of our wafer fab there and dedicated it to silicon carbide production. When we acquired Microsemi about 5 years ago, we found this particular product line of silicon carbide has been in production at Microsemi for almost 20 years. And it was specifically targeted for space and defense applications. What we've done in the last 5 years is transformed that same ruggedness and reliability for space and defense applications and moved that into sustainability programs. So whether it's trains or buses or pollution control or new any sustainability program requires some level of silicon carbide in order to be effective, whether it's EVs, industrial control, pollution control. We're amazed at the broad application base in which silicon carbide plays. And so, everybody thinks of silicon carbide as, Tesla and the next EV car. And there are far more applications that require silicon carbide, than just those applications. And in fact, almost all of our growth is not in EVs. It is in everything but an EV. So we're targeting buses, trains, electric grid, solar farms, microgrids. That's where almost all of our design wins are today in that area. And that is truly critical to, any company trying to get to net zero 2030, 2040, 2050. You really do not achieve that without silicon carbide. Doesn't happen.
It's been a fascinating technology to watch play out and get more and more traction in the industry, and the utility of it is clear. Russ, Menlo Micro does crazy specialty sort of fab plants. What sort of investments are you making for your future fabs and production facilities? And building off of what Michael mentioned, where this being a first step, not a silver bullet, of the CHIPS Act, about $50 billion is for semiconductors. So two-parter, what are you investing on? And do you think that $50 billion is enough for the industry, or do we need to look forward more?
Those are two pretty broad questions. I'll answer Menlo first in particular. So because of where we are in our life as matter of fact, we don't even like to call ourselves a startup company anymore, but we're still fairly small from certainly from a microchip or TI kind of standard, if you will, but we are in production. We've shipped almost a million units. The key for us is that, as Rich mentioned, we can't run down to Global Foundries or TSMC or whatever and say, hey, can you make my chip? Our manufacturing process, because of the material science, the material science invention that's used to make this device, it's just not compatible. Some of the equipment set is similar, but that's about it. So much like Rich, we need to have a dedicated line. So that's number one. And so I'm going to kind of talk a little bit about the priorities here because they all fit us. One is, the first priority is have this chasm of death. How do you get manufacturing going as a startup company? The second is, like what Rich described, because of the advanced nature of our technology, a lot of times the first adopters of those things are DoD type applications. So about a third of our design ins, if you will, are DoD related. So the next piece becomes security, right? And the fab that we're in, even though it's not in China, it is Chinese owned. And so subsequently, there's another accelerant there that makes it important to reshore, or as Michael said, we even looked at other, we'll call it alliances or allied countries that could have worked, but we just purchased a fab facility in upstate New York. And so that's the beginning of that. And then the next thing is actually supply chain. We talked a little bit about that. One of the things about CHIPS Act is what I'm glad about is people are at least talking about the back end operation. It's packaging and advanced packaging are the next critical pieces. And especially when you're looking at devices that we're not trying to figure out how to get, the multi-billions of transistors on a single device like an AI chip or anything, but similar to silicon carbide, advanced packaging for energy kinds of things is super important. So we're looking at how do we bring in some of that advanced packaging and partner with those things to bring those on shore as well. Our device itself is actually a switch. It's a mechanical switch, but it's made with a semiconductor process. And so subsequently we have, hundreds of little tiny, switches that are as thick as your hair on a device that transfers energy very, very efficiently. So very adjacent to, and not necessarily head-to-head competitive with, but adjacent to what silicon carbide's doing in grids and building management. And we're working on some programs where you're talking about scaling to thousands of amps and volts for distribution networks, because the technology that's been being used was invented 150 years ago by Thomas Edison, who was the founder of GE, where our technology came from. So,
I love the history that Menlo Micro has. Menlo Park. We talked about that with your CTO, Chris Kiemel, on the Moore's Lobby podcast a while back. So folks can go check that out if they want to learn more about MEMS, because it's fascinating. The CHIPS Act also, I mentioned, had about $50 billion of the $200+ billion. 50 of it was going towards semiconductors. In your perspective, is that enough to get it started?
I think it's a great first step. It's that is also a hard question. I was at a GSA executive conference. Rich was there too a week or two ago, And I think Michael mentioned this here too. Is you can also overdo this because obviously, as the U.S. is doing this, Europe's doing it, China's doing it, South Korea's doing it, Japan's got a program, and you can build plenty of capacity. I think I read an article. I wish I remembered who wrote it. That that at the beginning of the week here is that we can drive the cost of chips to zero if we really want to, and by building so much capacity. So. And we're already in kind of a weird place where everybody's talking about commitments for the next level of capacity, and there's the health of the industry right now from a supply standpoint is probably built up a lot. However, it also takes multiple years to get that capacity in place. And so the one thing I can tell you after 40 years in this business is that we never get the capacity in place at the right time. So we'll put it in place and then we'll fill it up and then we'll run out again. But I think it's a great first start. I do like how they're looking at not just funding big giant AI factories. They're looking at how do we get advanced R&D going? How do we look at advanced packaging? But again, the government's running it, and subsequently, it's got bureaucratic things associated with it. It's going to be more cumbersome than we would like it to be, but I think it's a great start.
Yeah. It would be nice if the supply came before the demand, but unfortunately, the demand's always a little bigger than the supply, it seems. Michael, you mentioned again silver bullets, first steps. How do we know if we have been successful here, or is it possible for us to know if we've really hit the mark?
So it depends on what your definition of success is, and I guess that's a little trite, but there's a couple of things that we've touched on related to your question, Daniel. One of the things that I don't think we're going to be successful on when it comes to the CHIPS Act is adding capacity for legacy technologies. Of the 52 billion that's been earmarked, I think only 2 billion of it is tagged for larger geometries, call it 28 nanometer and larger. The vast majority of this is targeted for the smaller, low single digit geometries, which plays into that's an NVIDIA play, an Intel play, et cetera, right? So no surprise. And by the way, it's not just unique to the CHIPS Act. When you look at CapEx spending for most of the semiconductor supply chain, I think less than $1 out of 6 is earmarked for legacy technology. So, that's a whole nother discussion why that is, and the kind of the tough love scenario that sets up. But I think that's ultimately going to be a fail in that. Automotive market, for instance, still uses a ton of 90 nanometer parts. A lot of IoT is built on smaller wafers with larger features or larger gate sizes. So, the wins would be, we've got a series of benchmark metrics. We know what the output. The domestic output has been historically for U.S. semiconductor companies. We can measure if that's improving, and I'm sure we will see that improve. And by the way, it's not just the U.S. semiconductor companies, right? Because like TSMC, for instance, is making a big commitment to establishing fabs, the first 2 in Arizona. So if we look at the total output originating here in North America, I think that's going to be pretty easy to measure. And then the other obvious KPI is related to all that is market share. Is our share of not just what we fab here, but our share of what we fab anywhere in the world is our share of the total semiconductor market going up. And I do think we are going to be successful there because the sorry to jump around on you on this, but I think the other piece of this that doesn't get talked about as much is that it's not just the 52 billion, which frankly feels like pocket change next to the cost of a cutting edge fab these days. It's the adjacent or related investment that comes from other places, these companies themselves, that I think scales that, pretty quickly. And that's important because I think the SIA is calling for in the next, 3, 4, 5 years, the global market to be $1 trillion, which is, that's incredible, right? And we want more than our fair share of it. This is where it originated, and I think that's certainly part of the objective. It certainly part of the objective for the publicly traded companies who are, focused on returns to shareholders, stock buybacks, and lots of other things, right?
Yeah, I mean that's the scale of like the healthcare industry. It's not small change overall, that's for sure.
Well, it's not small change, but then, and I think Russ touched on this. You have to compare it to the investments being made in like South Korea, which are quite a bit bigger, even the investments being made in Europe. And then you have to compare it to what's happening in China. I mean, the China infrastructure bill is it's larger than the U.S. infrastructure bill, the latest and greatest U.S. infrastructure bill, and more than half of the projects attached to the Chinese infrastructure bill are all geared towards strengthening their domestic semiconductor market. So on that basis, honestly, the 52 million and it's spread over time doesn't feel that significant.
We'll be back with our panel in just a moment, but keynote speakers for Industry Tech Days are sponsored by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from thousands of leading brands. Come discover, design, develop. And now, back to our panel.
Yeah, well, I want to say something that I know Rich is going to pile on big time because he knows this stuff even better than I do. Is a couple of things. One is we talk about the $52 billion, and that's kind of seed money. There's a huge umbrella of investment tax credits on top of that for CapEx, and so that I've heard, and I'm going to say I've heard because I'm not sure of the exact number, but that can grow into the $250 billion range. It's for it, and it's against kind of 25% of new equipment buys. So that's a big deal on investment tax credits. Most of the states also have dollars on that. So I wanted to make sure that got out there. The second piece I'd like to throw out there is on legacy, because actually we're leveraging legacy stuff very, very, very heavily. And granted, the amount of dollars are much less, but the amount of dollars needed are much less, right? To go put up, a 10,000, 10, 20, 100,000 wafer a month fab that's doing 28 nanometers or larger, is a whole different world than a sub 5 nanometer fab. And so from a cost standpoint, now I'll let Rich talk about that. So I'm not as negative on the legacy stuff. As a matter of fact, what we go in a lot and saying, hey, we're round off there. This is an easy win because it uses legacy stuff. I'm more worried about, are we really going to invest in packaging, and can we find a way to do that? Because from a supply chain standpoint, you could still hold up the whole industry in Southeast Asia just around packaging. So anyway, I'm sorry to interrupt the process there, but I know Rich knows a lot more about that part of it than I do.
Yeah, and Microchip is decidedly not a rounding error in this space for us. So I'd love to get your perspective.
I think when you add it up, the CHIPS Act money out of the $39 billion that's going to be distributed, a company may get 10 or 15% or some 20%, somewhere in that range. Then you add the tax credit, And then you add what the 1 or 2% that the states are piling on in terms of overall project. It starts to become real money in terms of investing in capacity expansion in the U.S. That difference now, when you look at either building a facility somewhere in Asia or somewhere else in the world, or going to a foundry, that delta now makes it financially viable to expand that capacity in the States, right? And so that's the big part of this. The U.S. is the only country, we compete worldwide, European companies, Asian companies, and for 30 years, U.S. semiconductor companies were the only semiconductor nation that was not supported by the U.S. by our government. France had subsidies, Germany's had subsidies, all of Europe subsidies, Korea subsidies, China subsidies. No matter whatever country you went to, you had tax holidays or you had support. And so the U.S. semiconductor industry, even though it originated here, was left to fend for itself and figure out how to be competitive and how to continue to grow. Right. And I think what's happening now, there's a trend and a different mode of thinking that this critical industry still needs to grow here in the U.S. And I like, it's not just about the money, but the CHIPS office has a more comprehensive approach to it. Now, they're looking at technical hubs and education and people, and because there's actually two sides to the issue that's occurred over the last 30 years in the U.S. One, it's the most capital intensive business, and there was no support for it in the U.S. But the second part of it was just having engineers, material scientists, people to hire to support the overall industry. More than 70% of our science, engineering, and technology grads are foreign nationals. Almost 90% of our postgraduates are foreign nationals. And then the amount of visas, work visas that are available, those are exhausted. It was 64,000 and 68,000. Those are exhausted in less than 24 hours, all gone. And then what you're left with is taking the rest of the people that you wanted to hire that graduated from U.S. schools and then moving them to some other country because we can't hire them here, which seemingly makes no sense as well, right? So I'm hoping that when this is all done, once again, we create a sustainable business model, right? It looks at investment, it looks at education, it looks at immigration policy, it looks at tax policy to make sure that we continue to feed this industry, or not even feed it, to just support it with the resources, the human capital, and the resources to make it continue to grow.
So, Rich, to make this keep growing, let's say we make you the CHIPS Act 2. Maybe it's like chips with a Roman numeral, like two I's in the middle, like a Roman numeral 2. We make you the SAR and the disbursement of the CHIPS Act 2 funding. Well, on a general, zoomed out scale, where are you investing to make this a sustainable business?
I would start with education. Bottom line is, one of my other positions at Microchip, I'm president of AZ First, which is our charitable outreach. And so what we do is we put money towards STEM or STEAM programs at high school or college levels or elementary school levels to try to entice our youth to get involved in science, technology, mathematics, engineering, whether it's through FIRST robotics or VEXA robotics or underwater robotics or different science programs. So we try to provide teacher stipends and fund teams and very much a grassroots effort. When you stimulate those young minds, we have a plethora then of creative people coming through our school system, and then developing the next generation of technology. we had somehow lost that, right? So if we can rebuild that, and that's what I love about the whole magnifying glass on the semiconductor industry with the CHIPS Act. Like I said, it's not so much the money, it's the visibility, right? Now everybody's talking about semiconductors. Now everybody's talking about, wow, that's a cool technology. Wow. Now I understand that. I can't have my cell phone. I can't have my coffee in the morning. I can't have my AirPlay in my car. I can't listen to my music without this critical technology, right? And so, just the fact that people are talking about it may encourage more investment in education and may encourage more of our young people to get involved in science, technology, material science. Russ's whole company is built on essentially material sciences. Semiconductors is built on material sciences, chemistry, biology, mathematics. All of that is involved.
Well, one of the neat things that Rich just brought up, and which is part and parcel to the CHIPS Act, is workforce development and partnerships with universities and things like that. So even as somebody as small as us, so we're putting up this fab in Ithaca, New York, and Tompkins County, and so we're right down the street from Cornell, not too far from SUNY Polytech and RPI, which is the engineering and masters and PhD. But there's a whole nother level of skilled operators. You need more skilled operators in the fab than you need PhDs. And so working with the community college system and all that. And what I'm really glad to see is that the CHIPS Act, that's a huge piece of the funding application process, with that. And it's turned out to help us dovetail into partnerships with these universities early on, which would have been much tougher, by the way, for a company our size, at this juncture. So the CHIPS Act adds visibility and adds a catalyst to that, I guess.
Yeah, that makes sense. I'd like to end on like a kind of aspirational note, but are there any other points anyone wants to hit before we kind of transition into, not closing statements, but as we start to wrap it up?
Maybe a couple to emphasize, because I think Rich and Russ, you guys, what you've talked about is a wonderful reality check. And packaging has been mentioned, the whole backend. But I think bears emphasizing, because we can have all the wafer fabs we want here, and if we've got to then turn around and send the wafers to Taiwan for packaging, what have we really accomplished? And by the way, that is kind of where we're headed. TSMC, the investments they're making in Arizona right now, everything that they produce is going to have to go back to Taiwan for advanced packaging. And and obviously why that's a problem is, at the heart of the current growing tension between ourselves and China is Taiwan is a sovereign nation. It's sitting there 100 miles off the shore of China, and something happens there, and we're all in trouble, whether you're in the semiconductor business or not. So global supply chains are going to be horribly disrupted if we jump the shark there. So I think it's worth emphasizing. We do need, the folks like Amcor and ASC and others to be investing in back-end packaging in some place other than where they've been doing it. Now we've got some of it in South Korea, which, by the way, shares a border with China. So we still have some challenges there. And the other thing that I think is worth emphasizing is we already have a lack of STEM folks in the industry, and not just in semiconductors, it's all over the place. So anything we can do to address that, and that's been that's not new. That's been growing and is somewhat chronic for all the reasons that Rich and Russ both talked about. And I think that's super important, as we move forward, not just in semiconductors, but for the industry overall. Yeah, and if you'll indulge me for a second, this is something that bugs me about all of this. And it starts with maybe a question to Russ and Rich. Are you guys worried that the lion's share of what's going to be distributed when it finally gets distributed, which, by the way, I think it's just this month that you can start applying for it. But are you worried that TI and Intel and the big guys are going to get the lion's share of it?
Sure, because I'm begging for crumbs off what their requests are going to be. Certainly Rich is at a different scale. But yeah, Rich, I don't know what your thoughts are that, but as I mentioned, we're madly trying to make sure that everybody understands we're not a little niche deal. So there is things out there that the ROI 10 years out on a small investment today is huge because the pervasiveness of the technology is going to be there. And investing in those leadership technologies is what puts you ahead faster than just now you have to do the other as well, but that's a big part of our message.
Having met a number of the members of the team that's in the CHIPS office, I have to say I've not met a more professionally or competent team of people making decisions for a government program ever. And I truly understand they're pragmatic. They seem to be wanting to do, all of them seem to have wanting to do what's right for the U.S. in their heart, not necessarily politically motivated, but motivated by doing what's right. So, we're trying to just put forth our position. I mean, we are a lagging semiconductor supplier for many of our devices. Our fabs in the U.S., produce a lot of those lagging edge technologies, but the fascinating part of this last 2 or 3 years, you could get plenty of 28 nanometer and down devices, but you couldn't get all of the power devices, the interface devices. It was all of the lagging edge nodes that there was no investment or capacity to support that. So you could build all of the 2 and 3 nanometer fabs in the U.S. you want. If the appropriate investment is not made in lagging edge technology, those factories are going to be idle. And I think the CHIPS office recognizes that there has to be a commensurate investment in lagging and leading in order for this to work. And so, I'm hopeful, after meeting a number of the team members, they are really taking a very pragmatic view at this, and looking to, and the people that I've met, truly, have the best interest of the country and the people and handling the money, in an appropriate way, right? To make sure that it's used, correctly. So I'm hopeful at this point after meeting the individuals involved. I don't know how Russ or Mike, you may not have met them, but Russ, I don't know if you feel the same way, but.
Actually, I do. Everybody from I'll call them the bureaucrats in the DoD or Department of Commerce that are kind of the origination of this to the folks that they brought into the CHIPS office. So we've had a number of meetings that have been. I've actually been it's very refreshing. I think is probably the right way to say it. Just 2 more quick points, because since you asked for them, and I think I as you can tell, I talk too much. But in any case, couple of things that I think are really, really important to remember. One is any startups listening to this? This is not something that you go through and look for VC funding for, right? If you don't have the private backing already, going into a government process is not necessarily helpful unless it's an SBIR or even some of the tech hub kinds of things where we're looking at small early funding of R&D projects. But if you're looking for something to help for capital equipment for ramping production of something, you need to have some pretty strong private validation, and I think from a government perspective, rightfully so. I used to complain about it, but it's real. The second piece is we all kind of need to remember the impetus of all of this, and I think Michael kind of touched on it at the very beginning of this. Is granted, there's a lot of windfall here of regenerating leadership in technology, regenerating jobs and manufacturing and our education system, and all that is well and good. But this has all started because of some other political issues between the U.S. and China, and Taiwan being in the middle of it. And I would invite. I don't want to get into an opinion piece here, but I think the best description of this, and I've talked to a couple of other folks in DC that the views seem to be very, very congruent with this, is Chris Miller's Chip War. If you haven't read Chip War, go read it. It really gets down to the nitty gritty of why some of the security things that have been happening that kind of drive all this stuff together. So anyway, just wanted to throw that out there.
As we push near the end of our time, I'm curious to hear from each of you, and we'll start with we'll do Rich and then Russ and then Michael. I'm curious to hear from each of you as you look forward into the future of the semiconductor industry and of your specific companies for the next 5 years, 10 years, even 30 or 50 years. What gets you excited and keeps you hopeful for the future of the space?
You know what? It probably should. It's I'm on the ESG committee, and and it's important to me. But I find it fascinating the amount of redesign and work that's going into sustainability, right? Essentially getting to net zero and reducing energy. I mean, at our customer base, everything is being redesigned, right? To lower its energy footprint. It doesn't matter if it's an air conditioner or a fan or a wall wart for a PC, the lighting, everything is being redesigned, right? Again, the hyper focus is on cars, but that's just the tip of the iceberg. Everything, and so when I look at semiconductor usage, we're being designed into everything from, tractors on farms. AI is detecting what type of weed it is before it sprays the insecticide so it doesn't waste chemicals, food production. During COVID, when they were trying to develop new technologies to find vaccines, semiconductor technology was used to test hundreds of thousands of vials at a time compared to traditional methods. So there was new technologies that came about and largely due to semiconductor technology advancing. So that's what I think is fascinating, why I stay involved, because the love of the semiconductor technology, because every year there's something that, rocks your world. Every year there's something that's new, or, who would have thought generative AI would blow up like this, and hyperscalers would be going crazy, and NVIDIA would be selling $80,000 GPUs and mind boggling, right? And microgrids. And so I just find the innovation and human ingenuity fascinating. And so that's what keeps me so interested in this and making sure we can do whatever we can to support that.
Much like Rich, it's funny. I get asked all the time, "Why are you still doing this? Why aren't you, off, doofing sitting on a beach or something like that. To be quite honest with you, I love it. 40 years in this business is all the way from the first what we used to call those old Motorola phones, the shoe phones, all the way to now we have foldable not iPad, foldable tablets, and now the whole energy thing, as Rich said. And to be quite honest with you, before I got connected up with the original folks that formed Menlo over at GE. Well, I was kind of dabble around. Well, we're doing a material science that replaces what was invented 150 years ago by Thomas Edison, right? And with that, creating something that's going to have a direct impact on how we distribute energy, how we create communication devices going forward. And that's just a blast. So they'll probably have to pry me out of the seat, and but the ability to continue to innovate. Everybody said, well, Moore's law is going to run out, and then semiconductors are going to. Well, look at all the stuff we're doing since they said that, 15 years ago, right? 20 years ago. And we're still going forward. We're still making things smaller and faster and making life better. And so that's fun.
Yeah. You mentioned shoe phones. Give me just a moment here.
Oh, you got one.
I happen to have one right here.
There you go.
There we go. Little Motorola shoe phone. Michael, what gets you excited for the future of the space?
I mean, it's everything that Rich and Russ just said. When you look at what's going on and you extrapolate out, so you look backwards and see where we've come from, and it's pretty amazing. And I'm a big believer in the exponential nature of technology, and I think we have moved into the exponential side of the curve. So what's coming at us, the innovation, the change, the impact is only going to speed up, and I think that's thrilling. My kind of short, glib take on this for a long time has been, the world is never going to use less processing power and storage than it used today. Just not going to happen. I mean, it'll be a little bumpy, but come on, the data that we're generating, you throw AI in, and what's going to be required in terms of hyperscale stuff that's moving to the edge. We're pushing a lot of the initial processing to the edge. What's going on with sensors? I mean, in many ways, we are still really in the early days of the mass adoption of a lot of this. I mean, we're electrifying everything, all forms of transportation, not just cars, skateboards, boats. And then once you've electrified it, we're applying AI to it. I was involved recently with a project that brought AI and some ADAS into the boat arena, so that those of us in the later stages of our lives who are getting boats but can't be trusted to dock the damn thing, the tech will do it for us, and it just goes on and on. So this is absolutely the coolest place to be, because it's at the center of everything. Even in the incredible advances that are happening in medical technology, I think Rich touched on this. When you start applying AI to the traditional iterative approach to drug exploration, all of a sudden you are finding all kinds of new and amazing compounds that actually can start moving us away from sick care, because I think that's what traditionally it's been, to healthcare, something that's proactive, to treating aging as a disease. I mean, it's just as we could talk for hours just about the future of tech going forward, and it's mind blowing. It's the stuff of science fiction, and it's like it's here, it's right now.
Well, unless one of you have figured out a way to turn back time, we are out of time for this session. But and also, if you figure that out, let me know. But thank you all so much for being here. It's been really enlightening.
Thanks,
Awesome.
Daniel. This was outstanding.
It's conversations like this that get me really excited for the future of the semiconductor industry. There are certainly some very interesting years and some fresh opportunities ahead of us. Thank you to Mouser Electronics for sponsoring this podcast. If you enjoyed it, please let us know on the Moore's Lobby social pages and share it with your friends and coworkers. That is the number one way this podcast grows and gets better. I'm Daniel Bogdanoff. Thank you for joining me today in the lobby, and I'll see you next time.